Hello, in this episode, we'll see how to train GAN to classify MNIST handwritten digits. Okay? And eventually we want to create some images like this. So these are GAN created images. So let's see how it's being done. The MNIST data load, we already did it, so I'll be quick. So we just import the library, and mostly it's a TensorFlow, the MNIST data sets, and then the various functions that's needed for neural network. Set key parameters. The image is MNIST images are 28 by 28, and we'll have 20,000 epochs and here. So here's loading the MNIST data. Okay, 60,000 training and 10,000 test samples. Select only one digit for training. And that's because GAN, if we want to train, and we could train for all digits, it's kind of harder. So let's just focus on training digit 3. So in the training data and test data, let's just keep digit 3. Okay. So like the training, this digit 3 and the label 3 for that, and have it there. Let's reshape and flatten the 28 by 28 for neural network inputs like 784 a column, and then scale it. The value each pixel ranges from 0 to 255. Let's just make it 0 to 1, the range. Okay, so for example, an example is looking like this. Okay, that's one of the handwritten digits in our training data. So in a GAN, we need helper functions. So let's have functions that load real and generate fake samples. The real sample is, let's have a random index of getting here from the data set, whatever the data set is, in our case, MNIST data set, and then have pull some of the indices and the number of samples, many data from the real sample, and then tag it as 1 because it's a real data. And then for the fake data, we first generate the latent points. So this is the same as before, and sample times the latent dimension is the multiplying them is the total number of random points. And then we reshape it to the n sample rows by latent dimension columns of random numbers, which we then use to generate fake samples. Okay. So here we need a generator. So take the latent points, generate them, and the generator will predict something, and the indicator, the label is 0 because it's a fake data. Temporarily, we also have a function called generate a fake random, which is not using the generator, but just generate fake random numbers. So these are just random numbers in the dimension that's needed. And then comes the very similar to our previous example, which is like the discriminator and a generator. So these are taking n input is 784, it goes to 128, and then 1. 1 being predicting 0 is fake, 1 is if it's real. So that's our discriminator. And the generator takes the latent dimension number of random numbers and then goes to 128 nodes, and then creates a 28 by 28 image. Okay. But 78 times 28, so 784 pixels. Okay, we need to convert it to a 28 by 28 matrix before plotting if you want to. And the GAN is, well, the discriminator weights are not trainable, so set it false. And then it's a sequential network of the generator and add on to a discriminator. Then you can summarize the performance, like if you have the real and fake samples, and have to evaluate and see how the accuracy of the real and fakes are. Then here comes the crucial part, the training for half batch. We get the real sample and we get half batch of fake sample. We stack the real and fake samples together and train the discriminator. And then have a latent point created for the GAN, and the GAN label is 1. All that's fake, we want to fool the discriminator, so we tell them it's like a real data and train the GAN model here. Okay. So this is training. So actually declaring the network, so we call all this function we just defined. Okay. And then let's train it. Okay. All right, so this is going to take a while. It's a large MNIST data set. Let's come back when we're done training. Okay, it's done training. Okay, so let's see how the image looks like. So we generate latent point and then use that to generate an image from the generator here, predict. So the XG test, generator test, is the image. We blow up, we rescale from 0 to 1, so let's rescale it back to 255, reshape to 28 by 28 to the image, and then plot. And the image here is, well, we can recognize it's a 3, isn't it? So this is how we can use a GAN to train MNIST data. Thank you for watching this episode.